Hello everyone. In this particular video, we will be discussing about the insertion sort and its implementation in Python. So insertion sort is a basic sorting algorithm in which each element is inserted one at a time at its right position. So now let us see how insertion sort works. Over here, I have a list of numbers and I need to sort the list of numbers in ascending order. The idea behind insertion sort is we take one number at a time and we insert that number in its correct position in the part of the list present left of that number. So what I'll do is I'll start with the second element in the list and I'll compare this number with the number present left of this number. So I'll compare 2 with 4. Since 2 is smaller than 4, I will insert 2 before 4. So 2 will come over here from here. So now the list will become 2, 4, 1, 3, 5. So what we did was we started from the second element in the list and we inserted that element in its correct position towards its left. So what happened was till now I can divide the list into two parts. The left part will always be sorted and the right part, so what we'll do is we'll take one element from the right part of the list and we'll insert that element in its correct position at the left of the list, that is in the left part or the sorted part. So now what we'll do is we'll take the third element in the list, in this case it's 1, and I'll compare this 1 with the number present towards its left. So I'll compare 1 with 4. Since 1 is smaller than 4, I'll further compare 1 with the number present left of 4. And again 1 is smaller than 2 as well. So what I'll do is I'll insert 1 before 2. So now the list will become 1, 2, 4, 3 and 5. And the sorted part of the list will become 1, 2, 4 and I still need to insert 3 and 5 in its correct position. To move ahead, I'll take the next number in the list, that is 3. Now I'll compare 3 with the number at its left, which is 4. Since 3 is smaller than 4, I'll further compare 3 with 2. On comparing 3 with 2, I'll find out that 3 is not smaller than 2. Therefore, what I'll do is I'll insert 3 between 2 and 4. So after inserting, my list will now become 1, 2, 3, 4 and 5. So the sorted part will be 1, 2, 3 and 4 and 5 I still need to place in its correct position. Now I'll compare 5 with the number present at its left. Since 5 is already greater than the number present at its left, we'll take no action and hence the position of 5 will remain unchanged. And finally I'll get my sorted list as 1, 2, 3, 4 and 5. So this is how insertion sort works. One thing that you would have observed is to find the correct position of a number, what we are doing is we are comparing it with the numbers present at its left. So if I take the first case, what I did was I compared 1 with 4. Since 1 was smaller than 4, I further compared 1 with 2. And again 1 was smaller than 2. So I moved ahead and I inserted 1 before 2. But in the next case, if we see 3 was smaller than 4, therefore I further compared 3 with 2. On comparing 3 with 2, I identified that 3 was not smaller than 2. Therefore, I decided to insert 3 between 2 and 4. So one thing that we need to notice, the condition to move left is either the index, I call it as I, is greater than equal to 0 or the number that we are comparing. In this case, I'll call 1 as key. In this case, 3 will be the key. So the second condition would be key is smaller than the number present at ith location in the list. So if both these two conditions are satisfied, then only we'll move towards the left to insert. So this is the basic implementation for insertion sort. Over here, what we have done is we have defined a function named insertion sort. In this function, we are passing the required list of elements over here. I call this as ARR. Inside this function, I have defined an outer loop. The outer loop will iterate through each index location starting from the second index to the last index. So therefore, the outer loop will have the range starting from the second index location, which will be the index 1, and the last index location, which will be the length of the list minus 1. Since in the range function, the end index is exclusive, therefore over here we are writing the length of the list itself. Then we are declaring a variable key which will hold the value of the current element. For the first iteration, the current element will be the second element in the list, that is the element present at the first index location. Then I'm taking another variable j which will hold the index of the element present at the left of the key. So j will be equal to I minus 1. Then we have the while loop. The conditions for while loop, as we discussed, will be either j greater than or equal to 0 or key smaller than the element present at jth location. That is, we will keep shifting towards the left until we reach the index 0 or we get an element smaller than the key. That is, we will keep shifting towards the left until we reach the index 0 or we find an element which is smaller than the key. And at the end, we'll insert the key at its correct position. Then to test this, I've defined a list of elements, and then I'll pass this list of elements to the function insertion sort, and then at the end, I'll print the sorted list. Let us execute this. Here we go. What we can observe is the list that we declared is sorted. So this was all about the insertion sort and its implementation in Python. If you liked the video, please don't forget to hit the like button and subscribe the channel. Thank you.